In the last video, I talked about vectors and scalars and how the methods of representation of vector. In this video, I would like to talk about problem solving with vectors. And to begin with, we will talk about what will happen if we multiply the vector with a scalar quantity. And this is what is happening, that a vector having a length a when multiplied by 2 undergoes only a change in magnitude and becomes 2a. Similarly, if we multiply by negative scalar quantity, then the direction gets reversed. So depending on what we are multiplying with, the changes the magnitude if it is positive quantity, and changes both the magnitude and direction if it is a negative quantity. So next is what is a unit vector. Now, suppose that we have talked about earlier about the Cartesian coordinate system, and in this system, let's a vector be denoted by this direction, and then now the vector now we multiply this vector with a scalar quantity, let's say 3, and this vector becomes thrice of its earlier magnitude. In this way, we can multiply with with a scalar quantity of higher magnitude. Similarly, we can multiply with negative quantity, and this would be the resultant line that will get extending from minus infinity to plus infinity. And then this is the line we are getting. So the unit vector represent the smallest line having magnitude of 1, and the direction same as this vector. For this vector, the unit vector is this a vector having magnitude 1, having this direction, making a particular theta with the x-axis. So this is about unit vector. So if we multiply any a unit vector by a magnitude, so then we get it only just either increase its magnitude, or we can just reverse this magnitude. So if we multiply with a negative quantity, so unit vector in reduction represents a vector having magnitude to unity. So next is let's next we will talk about the unit vector notation, and this is very important and crucial in problem solving related to vector quantities. So we'll talk about first in the dimensional and xy coordinate. Here this x-axis is denoted by a unit vector which is I, and so 2 in this is 2I, and it's generally there is a cap on this I, which notes that this is a unit vector in the x direction. You can the unit vector in this direction is denoted by j or j cap, and let's say we take a magnitude of 3 in this direction, and it is denoted by 3j. So if we draw line in which passes through the point uh, 2 2 3 and the Cartesian plane, then what we'll find that this vector from the origin to this is actually 2I plus 3 of j. So this is the very handy in describing vectors, and very important in solving in vector problems related to vectors. Uh, so here's a little animation that is showing how we add two vectors, and generally the convention is that to add two vectors which are perpendicular, you just draw it in such a way that the tip of this arrow touches the tail of the perpendicular component, and the resultant will be a vector which will be in the direction of this. That is, the tip will touch the tip of the vertical component, and tail will coincide with the tail of the horizontal component. So next is the unit vector which uh, extend to three dimension. And let's next take an unit vector I a comma j, and now this is the z-axis, and this vector is denoted by k. So a point and which is here will be denoted by some I, some j, some k. So this is the usual convention in representing vector quantity in three-dimensional Cartesian coordinates. So this is the vector 2 I comma 4j, and this and another vector is this, which denotes both 2I minus 5j, because the y-axis has been reversed in case of the second one. So uh, when we compute a problem in which two perpendicular vectors are involved, usually the Pythagoras theorem comes very handy and in solving those problems. And here we have taken a problem where a man walks 95 kilometer east in the east direction, and then and 55 kilometer north in this direction. So by Pythagoras theorem, we know that this c is equal to root over if this is a and this is b, then this is a square plus b square. So by this method we can solve this problem. Another method of